Now in this opportunity, as we identify linear functions, we also need to identify whenever they are given in a certain context. When we are describing a situation, we need to understand things like what the x variable represents, what the y variable represents, how they are interrelated, domains, and things like that, okay? In this exercise, we have this function. This is a linear function, y equals 15.95 times x. Now, the information we are given is that y is the cost in dollars of x representing the number of tickets. Based on that information, we need to provide the domain. Remember that the domain is the set of numbers used by the input or by the x variable in this case. Now, what it can be our reasoning in terms of what numbers we can actually use. And think about it. If we are talking about tickets, is it possible that x takes negative values? It doesn't make sense based on this context. So we're going to rule out all the negative side of the linear, of the number line. Now, another question. Is it possible to buy half a ticket, 1.5 tickets or things like that? Well, it doesn't make sense either. So it means that the domain will be limited just to whole numbers, okay? So that also helps you understand that this function specifically, is it going to be either discrete or continuous? Well, it cannot be continuous because the x values can only use certain values. So in this case, I would say that the domain is all whole numbers, which means it's all numbers greater than 0. It can be 0, okay? But then the next one would be 1, and then the next one would be 2, and so on. It's an endless list, but at least we know what numbers we're talking about. We could say something like that, okay? And so on. Ad infinitum, right? Now, taking this into account, we could graph the function using that domain. And as I mentioned before, the graph will lead you to a discrete function instead of a kind of a line, right? So we're going to do that. Because of a space, I think I'm going to erase this, and look at this. This graph could be something like this. We'll have horizontal axis corresponding to x, which starts at 0, then 1, 2, 3, and so on. And then, when x is 1, I know that one ticket costs $15.95, so I could do something like this. So here I have $15.95, right? Now what about 2? Well, 2, it will be twice as much, all right? And this corresponds to, all right, a 31.90, all right? 31.9 or whatever, right? And so on, right? These are the numbers that we could obtain, right? So 1591, 31.9, then this one would correspond to 47.85, and it will keep going like that. You could kind of have the graph just like this. We could also build a table, right? But it's basically what you are showing here. And that's it, okay?